Hello guys, this is the typical hydraulic excavator circuit of a Kawasaki K3V pump. So I will explain this as I can, as simply as I can. Okay, so maybe you are familiar of this circuit, but don't know how it works, or don't understand the circuit, how it works. So okay, I will try to explain it. All right, so I will explain. I will label it. Okay, so this one here is the front pump, the red color. The purple is the rear pump. The blue one is the auxiliary pump, which is the servo pump. This is a fixed type gear pump with a relief. So of course there's a strainer and then relief, control the pressure of the auxiliary pump. So other term, this is the servo pump. Okay, the servo pump, which is constant pressure. Okay, this front pump here, this is variable. These two pump here, these two pumps are variable swash plate axial piston type. Okay, so this one here is the stroke piston, okay, or servo piston, you call that. Okay, so this is the stroke piston. This one here, the stroke piston. So there's a large area here and the small area. Okay, and we have here the regulator side control. So this is part of the regulator. Okay, this part of the regulator. Okay, so this one here is your servo spool and sleeve. Okay, this is control the tilting angle of the pump if this one shift. Okay, this one here is the feedback lever, so the attached to the stroke piston. Okay, so I will show you that one. Okay, so this is the stroke piston. This is the small area here, and this is the large area. This the lever, this is the feedback lever, this one here. So this one is attached to that pin. Okay, like that. Okay, all right. Okay, so this is the stroke piston. This one here is the where the swash plate connect, or the cam connect. So that one there. Okay, so that's the feedback lever, connect to the servo or stroke piston. This one here, I use the small pointer. This one here is your flow control link. Okay, this one, flow control link and spring. By the way, this spring here are adjustable. That one there is adjustable. Same here, you can adjust that spring. Okay, so this is the link, flow control link, and this is the power link. Okay, spring adjustable. So there's an inner and then there's a outer. Okay, there's an inner, there's an outer spring. That's how you set this. That's that spring set your power curve. Okay, this one here is the pilot piston. Okay, and this signal is your pilot pressure. Okay, this one here is the power link. This is the this control here is your power control. So you have your sleeve and spool. Okay, so same on the rear. So I show you that one there. So this is the sleeve, this is the sleeve. Okay, this is the sleeve. So this is the land here for the front pump, rear pump. Okay, this land here, see there's a hole, there's a drilling. See that drilling? Okay, so front pump pressure, rear pump pressure. So if you go to the rear, this is rear pump pressure and front pump pressure. Now at the back here, that is your power shift. Okay, there's a bore and there's a piston. So this is this piston here has a different sizes, okay, depend on the power curve, okay. So that one connect here. So when there is a pressure acting here, this spool move and then pushing this spool. So this is the spool, okay. So this area here is the front pump pressure, and this area here is the rear pump pressure. So if you go to the rear pump control, so this area here is the rear pump control, and this is the front pump control. So it is called a summation multi-land spool and sleeve because it has a companion pump, okay. So this is the spool. So the first land, if you're looking on the front pump, so the front pump pressure, so if you follow the circuit, check valve and then see, so when this pressure is higher than the servo pressure, so this check valve will open and this check valve will close, okay. So this check valve here on the K3V small displacement, it fitted to, if it is not fitted in the regulator, it fitted in the pump head, okay. So there's two check there, one at the head, one at the side of the here. There's a two check, okay. So this is the front pump area, and this is the rear pump area, and this is your power shift area here, okay, which is from your proportional solenoid pressure reducing valve, okay. So this one here, there's a solenoid. When there is a solenoid, that is a proportional pressure reducing valve that controls your power shift, okay. So same also on the rear. So this one here is a variable horsepower control because it has a power shift command, okay. And then this is this control here is this flow control here is a negative flow control. So negative flow control, when the pilot pressure increase, the pump displacement decrease. Remember, if it is a negative flow control type, the pump displacement is inversely proportional to your pilot pressure. Remember that if it is negative flow control type. So how do I know it's a negative flow control type, this circuit? Because of the link. See this link here? When you see a diagram, this drawing like this, front and rear, see, it's a negative flow control. When it is a positive flow control, so a positive flow control is a difference. The pump displacement is proportional to your pilot pressure, okay. So a positive flow control type, it has a fulcrum here. There's a drawing, there's a symbol like that. So same also on the rear. So if you see a symbol like that, it is a positive flow control type regulator, okay. So I show you the links. So these links here, I show you already this one, okay. So that one. So when this one here, this is a negative type flow control link, okay. So when the hole here, okay, this is where the link locator locate. So that one there, okay. When see this link locator, it has a chamfer, okay. When you install this on the regulator, it's like that, okay. And then next to that is, if you see a regulator, there's a like that, okay. So show you, so if the chamfer is on the top, so remember there's a circlip here. So a normal regulator has a circlip, but the other type of regulator is a plate type, so you can't see it. So if you want to double check, you just remove that plate, okay. So if you see a chamfer on the top, that is a negative flow control, okay. Remember that. So this is a negative flow control because it's in the hole is in the bottom. When it is on the positive, this is the positive type, okay. The positive type, the small hole is on the top. So when you put the link locator, so this is how it go, like that. When the chamfer is on the bottom, that is a positive flow control. Remember that, okay? So remember that. So that's a positive link, flow control link. That's a positive, and this is the negative. Okay. So on the circuit, they put a distinction. They put difference. So you have to meticulously check the drawing. Okay. So if you miss that, you miss the control. So this one is a positive flow control type, and there is a fulcrum. Okay. So how this is very important here. I will explain that later when I explain the flow control. Okay. So this time I just give you a overview of the diagram. Okay. So let's put a negative flow control first. Okay. Now, okay, I think I cover everything. So this controller or regulator, okay, the code of this one is normally K R, and then depend what size of the pump, 112 or 60, 112, 140. So let's put X first there, because let's say we don't know the size of the pump. And then KR3 X, and then because it's a variable horsepower control, variable meaning, so if this is your graph here, so horsepower control variables, you can go like that, you can go like here, and you can go depend on how much current milliamps you have. So this is 1, 2, 3 horsepower curve. Okay, so that's a variable. Okay, so depend how much milliamps you put on that solenoid. Okay, so because it is a variable, so 9, and because it is a negative flow control, so N. Okay, so that's the code of the regulator. Okay, if it is a positive, P. Okay, so if it is a, it has a like a, the flow max is two stage, when the maximum flow rate is 2 stage, so C. Okay, so two stage flow, maximum flow type. The symbol here is not like that, but a kind like this. Okay, I show you like that. Okay, and then there's a piston. So this one here PI, and this one is PM. Okay, so when you see a symbol like that, there's a link here, and then spring. So that's a 2-stage maximum flow control. Okay, so but this one here is a normal only, but it is a negative flow control. Okay, because of the link symbol. So guys, the next video I will continue, guys, so that it will not too long. Okay, I will explain the servo circuit and the rest of it. Okay, thank you.